Alright, time for another draft science video presentation. Continuing on the same kinetic energy and now paradox theme of the fact that it really does create free energy. This attempt to keep both momentum and kinetic energy as viable descriptions of something real. Either way you go, you're in trouble in terms of keeping them both. And if you, I would argue, make kinetic energy the right answer, you'll get wrong answers. You won't be able to land on the moon because momentum is the right answer. It always was the right answer. So anyway, it's really funny that there just aren't any experiments. I mean, simple things haven't been proven. Like, if I take the 5-ton train going 10 miles an hour and the 10-ton train going 5 miles an hour. So I just take any inverted mass to velocity ratio objects, make them toy trains, doesn't matter, and crash them into a spring. There's a real unanswered question in terms of a physical experiment. Now, I can show you, stack exchange question, the very question being asked, and the answers are contradictory and dominated by the one that wins is the one that says they actually compress the spring based on their kinetic energy. That is, they have the same momentum, yet they compress the springs proportional to their kinetic energy, which is one compresses it twice as much, which can't make any sense. I just can't. I don't think. But anyway, the fact that there's just no experiment, something so simple, and I can't just go to a YouTube video. I can't just point to a physical experiment that has been recorded in history. I can't find a 1960s video that shows it. Just really surprising. Not that I'm implying a conspiracy. I just mean it's part of what makes this whole conversation quite irregular and bizarre even. So anyway, we'll go through what I would propose as the experiment that I will conduct if I can't get somebody else to do it. The aerosol breeze guys does seem to be still around, so I will see if he can just, instead of me having to do it. And part of that is a kind of laziness, just because I have it's just to make space for it, I have to engineer something, and then I have to engineer the pieces, and I really don't buy things, and so it's I'm not the best candidate for doing experiments. I'm not equipped. Even though I really am interested. The fact is, I like doing that kind of stuff. Frankly, it's just that I have other stuff my brain wishes to do and contemplate and spend its time doing. Alright, so the simple principle is, once again, so Professor Lewin's experiment basically just takes an object, okay, with given mass and velocity, sends it, puts a spring on it, so that's the important feature, it has a spring, and it's going to crash into another object that's twice the mass. Okay, so 2x the mass. And what happens is this leaves with 3/4 of the velocity that this one. Oh, jeez. Gotta keep these things straight. 2/3 is a distinction. 2/3 is different than 3/4. So this had a velocity of whatever x, and so this would be 3/4 of this velocity. Now, technically, to be rational, momentum-wise, it should be 1/2. Okay, so 2/3 is a lot more than 1/2. It's 30% more. Well, it's not. But anyway, it doesn't matter whether I'm getting that part right? That's trivial in comparison. And then this object leaves, so the idea is that 100 goes in, 30 goes this way. Okay, so 100 goes this way. So into the experiment, all you're doing is putting 100s of anything, energy. And then you get 30 going back this way. And you get 130 going this way. So the end result is as I speculate, the springs are what's getting compressed for free. So that's the free energy part. The spring is compressing for free, and then when it expands, you're getting that expansion energy for free. You didn't have to do work on the spring. The work was done by the fact that it's moving all in the same direction. So anyway, this is clearly, if you want energy, if you like energy, more momentums, okay, is more momentums, okay, that's just a fact, and it means something. It's more weight, it's more ability to work. So that's the paradox. Now the experiment is decisive in the sense it's right there in your face. Professor Lewin performs the task, okay, and he turns 100 into 130 this way. Who cares about this stuff, right? Because when you're doing energy stuff, you don't really care about the recoil. You just care about the cannonball, you know, blowing a hole in your enemy ship thing. Recoil, meal coil, who cares? So I would propose the experiment that could decisively do this. It's really simple. Is, all right, you just take your object of whatever mass. Now, as practicality, you might have to go with a minimum of 10 ounces just to make them manipulatable, and then you double it to 20 ounces, and then 40, and then 80, and then 160. But the idea would be is to just duplicate the experiment. I'm thinking of doing it based on suspending objects by, say, you know, from ceiling to floor by 2 strings, like a pendulum, and just have them all in a row, you know, or in a row, and in a row, and then just banging them into each other, because the gravity, the amount of curvature will be so minimal that the work you're doing in gravity won't destroy the energy. It's more energy than you need, frankly. All right, so the idea is to go through these iterations of spring, 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 spring. Okay, and they can't be touching each other, so you know, keep them an inch apart, the ends of the spring, so they don't touch each other. So what will happen is, so you do a row this way, and then you put a lever, okay, on this end, you know, with a pivot here, say a 4-to-1 lever. Okay, so now 4-to-1 would be basically just inverting what you've done to the mass. So you have 1 mass, 2 mass, 4 mass, 8 mass, and now you have a lever, and the lever is going to send back. Okay, you're going to start with a small mass again, and then go up to the 2, and then go back up to the 3, and then go back to the biggest one. All right, same idea, spring, 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 spring. And the thing, you might have to make this longer, because what you want to have to get rid of is this action. So the 30 this way, and the 30 more this way. Well, it's going to be more than 30. It's going to be like 45 or whatever, and then it's going to be 85, and well, 105, and then it's going to be 200 or whatever. The recoil, yeah, you know, they're going to bang into each other back here. So your energy is going to go through here. You go from 100 to 130, you know, to 52 or something, 200, and blah blah blah. And then you'll have, so you're basically just using the lever to take the slow moving object and make a fast moving object. So that'll just be your conversion mechanism, and it is a balance. It's a scale, you know, essentially. And so you're just taking the weight on one side and converting it into a momentum on the other side, a weight on the other side for the small object to be the higher velocity. So you'll get back the velocity, the fast velocity. So you're going to go slower and slower, because it is 2/3 here, and then 2/3 a reduction again, and then a 2/3 reduction again in the speed. So it's getting slower and slower, and then you're going to regain the speed again, do the same exact thing. And so you just have opposite levers, you know, and the idea is if Professor Lewin's experiment is correct, that's all, this is his experiment right here, okay? And theoretically, all you're doing is advancing it into these more scales. And so the theoretical paradox exists. The free energy solution It obviously implies free energy. There's no way to escape it, because I'm going to have more momentum here than I started with here. That more momentum is going to push this thing pretty good. This thing's going to end up moving, you know, with 200. It's going to start with 200. This one started with 100. So I'm going to have 100 going in. I'm going to do the first push. All right, I'll end up with 200 by the time I get here. I'll convert the 200 into a, you know, this is going to have big mass, little velocity. This one's going to end up with big velocity, little mass. All right, but I'm still going to have the same number. And then I'm going to end up with 400 here, right? Or whatever I'm going to end up with, you know. And then the 400 is going to go back this way. So it's not only perpetual motion, but it's going to be getting faster and faster and faster. So it seems impossible that nobody would figure this out, right? If this was free energy, that no one figured this out. It's just so simple. So either it's just plainly amazing that no one did this simple free energy, made this simple free energy machine, or there has to be something wrong with Professor Lewin's experiment. There has to be some shenanigans, right? I mean, he's overtly showing us the principle. I mean, the object does leave with more than half the velocity, which means, and it's heavier, twice as heavy, so it does in fact have more momentum. Momentum will push a lever. I mean, how do you escape this as being interesting? So, yeah, let's do the experiment. So let's do it. Let's build the perpetual energy machine and the perpetual free energy machine. There's both, you know, you get both in the same package. Or let's prove that Professor Lewin, MIT, you know, you can only say they committed a fraud of some kind, right? I mean, is there some other explanation? Like they accidentally made this happen? You know, you know, what could the accident possibly be? What could, oh, the timer didn't work. I mean, they look like pretty expensive timers, frankly. What exactly am I going to blame for the fact that he did the experiment? That somehow he proved it. I mean, he did it. He took 100 momentums and he made 130 momentums in a direction. Again, who cares about this stuff? So the point would be is you got to make it so it's big enough. You know, you go through enough transitions and you slow down enough here that by the time this one hits this surface, these have already stopped recoiling. You know, they've stopped swinging. So this one especially has quieted down. So you're basically saying this one's going to recoil with 30. Okay, so, and it's going to swing back and it's going to oscillate. Okay. And then by the time the experiment gets all the way back to here again, you want this one to be quiet. You want it to be back to being not moving. And then, you know, recycle. If you go too fast, obviously this one will still be jiggling all over the place and the whole thing will get, you know, messed up because it'll be conflicting energy will hit each other. But if you allow the recoil to dissipate into the environment, this should work. Just keep going and going and getting stronger and stronger and stronger. And you could almost make it so it's just a perpetual, it doesn't get stronger and stronger by just putting these balls on rails. You know, like I said, I'm trying to think of ways of eliminating friction, but we're gaining so much more momentum. I mean, 30% is a huge amount of gained momentum with each interaction that you could almost say, who cares how much friction there is? You don't care how much you're losing, but you can't, you know, you almost can't make something so frictional, you know, so bad that you use up 30% of the energy. That's pretty hard to do without running it through glue. You know, without trying to make it have friction. If you're making any effort at all to reduce friction, 30% is an easy target. So just if you put these on rails, you know, just a little rail system into a lever, back into a lever, you know, 2 rails. All you need is 2 rails and some different weighted, you know, steel balls or something, See, the point is the spring part though. You want the springs on them. So an air track isn't ideal for this because as the weight gets heavier, the air track doesn't work, and blah 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 blah. So so I didn't think through that part. So that's why I'm going with the suspended idea, because it seems to me that'll work. So even if, like I say, if you had an arc and you were going into gravity with each swing, and hitting when you've lost your a bit of energy by going up against gravity, even those losses won't equal 30%, so it should still work. So that's sort of my point. So I'm just leave it to you. Does anybody have a simpler way of doing it? This seems about as simple as you can get, right? To build construction wise, this seems pretty simple. You just have two parallels, put them in inverse position, and use a lever to convert the slow velocity into a high velocity. That seems to me it'll work. So yeah. So, I'm just saying that if somebody, no one has explained how the Professor Lewin experiment isn't free momentum. It isn't just generating momentum. If I just keep just multiplying the mass, I'll just keep increasing the momentum. So until somebody does explain that, we're stuck with this. And so I'll see if the guy can do this, and if he can't, I will in some way, in some form or other. I was thinking using fluids, and that's, just because it'd be really easy. You just use bottles with different amount of fluid, but the problem with fluid is it moves inside the bottle. So I didn't think of that. So you'd have to like freeze it or something. So it gets more complicated. I guess it would still work, right? That's not that complicated because you'd have a lot of time before it melts to do the experiments. You could just freeze the bottles with the different weights ahead of time. So if somebody else has a better idea of how to re-perform the experiment without losing any of its essence, I'd be interested in such. So, yeah. And then the other simple experiment, well, maybe I'll go to that. So I'll go to the stack exchange question and pose it to you. That it is kind of bizarre. I mean, some things you should be able to admit, even if you think I'm completely wrong and completely an idiot. You should be able to admit, just like the Eddington experiment, you should be able to admit that, yeah, 400 times better resolution from space, they really should have done the experiment by now. They don't even need an eclipse from space, and just a crappy camera is all they need. They really should have. You should be able to say that, and you should be able to say that in 350 years of doing these kinetic, and in 350 years of controversy regarding the true nature of energy, you think somebody would have thrown two things of the same momentum but different kinetic energies into a spring to see if they compress it the same. That doesn't seem like that seems like an experiment that really should have been done by now, lots of times. Anyway, I'll be back. Alright, should be back. Alright, so here's a stack exchange question. Carefully worded, so we could just show that you have to be so careful how you word these questions because of all the shenanigans. So he says, an object is headed towards a spring at a constant velocity. No external force will act upon it except the force applied by the spring itself after the collision. Let's say the spring is of arbitrary tension and arbitrary length. So we're just using any spring, and we're going to crash two different objects into it and see how far they compress it. My question is whether the kinetic energy of the object will make a difference in how far the spring is compressed, or whether it's only a matter of momentum. Now, obviously, it's only a matter of mv, but if you square the velocity, okay, it means that the object, okay, that has the faster velocity has more energy and therefore should compress the spring twice as much. So you have, again, inverted mass to velocity ratios, that is 10 to 5 and then 5 to 10, and you're throwing them into a spring. For example, below, object 1 and 2 have the same momentum, but object 2 has twice the kinetic energy. Now he made twice by using 0.25 kilograms and a velocity that's 4 times the speed. which just complicates it unnecessarily. So the half thing is so much simpler, so why bother with doing it this way? But I guess it also helps because this gets more to the bullet analogy, you know, and the fact that does the bullet actually have more energy than the recoil of the gun? Does the bullet actually have 2,000 joules and the gun only has 4? So it does get to that question. So these answers were just so useless. So I don't know who this Kazu is. So who posted it? I don't know. These are always a little, you know, the way they thread these things is hard to understand. So they got these 2, 1, 1, whatever this means, who the hell knows, and that these are the real answers. So you're saying, what is this stuff then? You know. So he says nothing is compressed by energy and momentum. So this is, you know, the word game guy. I mean, obviously we know the matter is what's moving and it's going to compress it, the material object. But the fact is, the reason why it's going to compress it is because it does have energy. Energy and momentum are just qualities that physical objects which actually do the compressing can have. Yes, and we're talking about the quality and how that quality will have an effect on the spring. It doesn't matter. So, just word game. The compressed distance x is determined by mv squared times kx squared. So he's obviously saying kinetic energy will decide, and that means the springs will be compressed a different amount by the two objects with the same momentum. But he completely misses that. So x depends on both m and v. Whether you call that depending on momentum or depending on kinetic energy is kind of up to you. No, it's not up to you. There will be a decisive answer. If kinetic energy is correct, then the spring is compressed twice as much. If momentum is correct, in terms of being the influence, the thing that compresses the spring, then the springs will be compressed exactly the same. So he doesn't even get the fact that, you know, and he's talking so pretentiously, you know, that clearly there's two different answers here. If kinetic energy controls the spring, then the spring will be compressed 2 different amounts. Okay, so then this guy says at him, according to your equation, x, in the case of the 2 example objects, is directly proportional energy, not momentum. So he's clearly just saying, you just said it's kinetic energy, not momentum. No, x squared is proportional to energy, and meanwhile x is proportional to p. So what's the point of this proportionality crap? We know the two give a different answer. If momentum is right, the springs compress the same. If kinetic energy is right, they compress completely different. One compresses the spring twice as much, twice the distance. If you allow extra factors of m, so again, I don't know what you mean by whether it's energy or momentum. So again, he's admitting he hasn't figured out that if kinetic energy is right, the spring compresses more. It depends on both m and v, and you can call that what you want. I call it more compression or equal compression of the spring. Those are 2 different answers. Amazing. It's Cat Whisperer. The conservation of momentum would only become relevant if the spring was not attached to, say, a wall. So now we're back to this wall argument. You know, that somehow if you're attached to an object that doesn't move, it means you get more energy. And it would have to be a lot more, frankly. If it's an equal and opposite reaction thing you're saying, and you know you have, because it's attached to a wall, there's no opposite reaction because the wall doesn't move. It doesn't mean that the wall doesn't have an impulse in it. Okay, so that would be the argument. The absence of movement does not mean it's not moving internally. Then the center of mass would move and blah blah. That's a different problem, probably not the one you're referring to. Quite obviously, yes, that's off the subject. So here's an answer, 2 answers it says. I don't know. When the objects collide with the spring, there will be a change in both its kinetic energy and its momentum. So, you know, again, the change is a transfer, I would argue, quite obviously. But whatever. They're transferring what they have. And that fits with the whole relativity argument or whatever else. Whatever their absolute motion is, they're now combining their absolute motions and connecting them. And by connecting them, there is some possibility they will transfer elements of their motion to each other. That is, one will give quarters and one will give euros or something. They're going to exchange. There's some change that's going to fly out of one's pocket and go into the other guy's pocket and vice versa. It is the kinetic energy of the object that determines the compression of the spring. So that's he states it, but he can't provide a link to it. So imagine 350 years, this was debated for hundreds of years, rather vigorously, 150 anyway. People degraded each other's integrity and standing in the world as a scientist based on the arguments for and against this fact. And yet, no experiment. Okay, if the objects have the same mass and the same velocity, they will have the same momentum and kinetic energy. Yes, they have the same momentum, or they have the same kinetic energy, but kinetic energy and momentum won't be the same number. So their compression won't be the same. So yes, it's circular for both. Okay, momentum is completely functional, and kinetic energy completely functional based on mv, but the outcome won't be at all proportional or the same or any of those things. In terms of the effect on the object on the spring, you can apply the work energy theorem, and which was meaningless mush, which is force times distance, which doesn't mean anything. Distance where? Distance how? This is a transfer of energy. There's no distances involved. Which states that the net work done on an object equals the change in its kinetic energy, and done by just multiplying force times distance, which doesn't tell you anything. In the case of the following equation, applying the theorem of the kinetic energy to that before the collision, it is 0 at the maximum compression of the spring when the object is brought to a stop. Yes, duh. But it isn't brought to a stop. It gave away all its energy. That's the argument. Things stop because they don't have any more energy. They lost it. They gave it to the environment. They gave it to friction. They gave it to this. They gave it to that. They gave it all away. The bowling ball stops because it gives away its velocity. Jeez. The spring does negative work on the object, taking its kinetic energy and storing it as spring potential energy. So again, who cares whether it's potential energy? We just want to know how much it compresses it. And clearly he's arguing for the kx squared version of the equation, which is he's saying it's kinetic energy that will compress the spring. In your example 2, even though it has the same momentum as the object 1, has twice the kinetic energy, so it will compress the spring more. So again, that to me is paradoxical, because it's basically saying, okay, two things with the same weight, I'm going to put them on that lever. Let's put let's just make a scale out of it, put it right in the middle. And now I'm going to drop those, I'm going to hit the scale with those two objects. And their argument is the scale is going to do this. That the faster moving object weighs more. This has more kinetic energy. Well, I would argue it can't possibly weigh more because it has the same momentum. And momentum is its weight. Hope this helps. No, a link to an experiment would help. This mathematical gibberish doesn't explain anything. It doesn't provide any insight. It doesn't have any show me impact at all. And the fact that everybody's satisfied that somebody just does this crap and they don't need to see anything is really irritating. I mean, I find you offensive that you people are all satisfied that this is an answer to the question. That this solves the problem. This proves it right here. I don't need to show you anything. I think you do. Yeah. All right. So this is 6. I don't know what that means. As mentioned by in the comments, who was a jerk. Okay, he's the idiot who says, "What's the difference? Doesn't matter." Yeah, it does matter. Twice as compressed and half, and equally compressed are two different outcomes. I don't think it's correct to really say that the spring is directly compressed by either momentum or by kinetic energy. So what? It has to be compressed. And if it's the same compression, it means momentum is compressing it. If it's different compression, it means kinetic energy is compressing it. I mean, how can they screw this up so much that they can't even get that's the simple point? Okay, as the comment rightfully points out, springs are compressed by force. So again, that's not the issue. The original guy asking the question didn't have any misunderstanding about force and energy and all those words too. He knows what they sort of mean. The relationship between the applied force, kinetic energy, and momentum. There's no relationship between kinetic energy and momentum except that one is Newton's theory and one is Leibniz's theory. And it's a terrible history. Leibniz did it for religious reasons. He protested, created fake physics, and it's never been proven with an experiment. Will all depend on situation you describe. Yes, if you're trying to land your lunar module on the moon, you don't want to be using the kinetic energy theory because it isn't proportional to getting right answers. Alright, that said, it can be easy. I'm sorry, I am editorializing a little more than I should. I'm trying to be fair. But this is, your people are the ones who aren't fair. Again, just like with the Eddington experiment, you're just completely unfair. You won't concede. Really hard experiment, got 10% of the quality of the experiment. I mean, the quality of the photos was shit. 10% of the quality he was hoping for. You know, and they made a New York Times headline, Einstein right. You just don't see that as being kind of crappy science. Come on, you can't admit that's not what science should look like. That said, it can be easily shown that in your example scenario, given the same momentum, we get different values for spring compression. Well, if you're using that formula to do, we know that kinetic energy can be determined by Ke times 1/2 mv squared, and energy in the spring can be shown as Pe equals 1/2 Kex. So again, now they're saying that potential energy. So, you know, they screw things up is when they put this P in for potential. You know, it's the same as the small p for momentum. So it does create an optical shenanigan kind of a thing. There's no such thing as potential energy. Gravity is an active force. It's not potential energy. And so all you're saying is you're standing on the riverbank. And it's like somebody saying, well, you have the potential to go that way. Yeah, if I jump in the river will carry me that way. It doesn't mean I have anything, right? I'm dry as a bone. I'm not going anywhere. I don't have any quality of anything. But yeah, throw me into the stream, then all of a sudden, yes, now I'm going to start moving. But I never had anything called potential energy. Due to the conservation of energy, that gives us blah, 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 blah. Frankenstein marries Kermit the Frog. This is what you end up with. A talking piece of shit. Yeah. Anyway, your example, if you solve for x, will object 1 will compress the spring x to the square root of 1/k. For the object 2, the spring will compress x equals 8/k. So it's completely different answers. You can see the increased kinetic energy while leaving momentum the same will increase the compression of the spring. So again, just more theoretically, that's what I say the math says anyway. So instead of showing an experiment, they just tell you this much. This means that the compression is proportional to energy, not momentum. So that's their assertion. They're asserting that the spring will not compress the same. That even though they have the same weight, momentum, they won't measure the same on the scale. So I put them on the scale, they won't measure the same. I mean, you can sort of logically know that, you know, if you stand on a scale, you're going to weigh whatever, 150. Just use me as an example. But if you take a 50-pound kid and you drop him a foot or two, he could weigh 150. So, I mean, you know that's the way it really works, is that the weight is just a measure of your velocity into the scale. And that gravity gives you a certain velocity into the scale. Yeah, come on. But it does not necessarily say anything about the cause of the compression. So he wasn't asking what the cause was. So why put the cause in quotes? He's asking for the simple answer. You're giving him the simple answer. You're saying no, momentum. You're not going to see. Momentum means nothing. The spring will be compressed by kinetic energy. So the two, even though the two things have the same momentum, your lever, your measuring device, your scale won't see that, because momentum doesn't matter to the teeter-totter, so to speak. Kinetic energy does. All right. But no experiment, no link to any visual proof. So if you let the ball hit the free spring, you'll find the momentum is also conserved. It's not about conserving. So the argument is do the two objects, does the momentum compress the spring? Period. So again, another fake straw man here. And that the energy transfer is never complete. The ball never comes to a stop. Well, that sounds kind of retarded right there. The ball never comes to a stop? Says you. Alright, the reason the momentum is not conserved but energy is here is that the system is subject to external impulse. So this is just so bizarre, right? I mean, you can't make it simpler and less, fiddles with. Springs are fairly efficient. They don't get burning hot. They don't do a lot of stupid things. So why are you even bringing this crap up? From the fixed end of the spring, but not to the external work, because the fixed end is fixed. So one absolutely should not say that the spring is compressed by anything except force. So more mush about whether or not what we call the crap that's compressing the spring. The question is, does it compress? Do the two objects compress the spring the same amount, or does one compress it twice as much? That's the question. They can't even find the subject. Very good point. I added that springs are compressed by force, since I didn't remotely address that in the answer, and absolutely should have. So again, the question is, how much is the spring compressed? And here they are telling us that, well, you have to understand that it's force that's compressing the spring. Who cares what you call the crap compressing the spring? The question is how much does it compress? I mean, so bad. And then this guy, sorry, I was editing my answer and posting it before seeing yours, which essentially says the same thing. Not trying to be one up on you, Bob. Blah, 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 blah. So that's the best they could do. These obnoxious, arrogant bastards, who have kicked me off this forum for asking questions like this. That's the best they could do. So they can't produce any evidence. 350 years, and we don't have evidence of two objects of inverse mass to velocity ratios hitting a spring. I mean, it's so pitiful. All right. So, now I'll just throw that in. Blah, blah, blah. All right, so we'll do some comments, I guess. It's not much. There's not anything, really. Nothing on the subject much. Blah, 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 blah. So, Matter Dirk. For some reason, catapults and tortoisets come to mind. Why? Why? This subject is a paradox created by objects hitting each other. Why does this come to mind for you? They're designed to maximize the velocity. They're designed to put a bunch of energy into an object. And obviously you have to, the only thing, you can't change the object's mass. So all you can change is its velocity. I mean, I can't, once I decide on cannonball, I can't change the cannonball. So I have to change the force that I'm pushing it with if I want more out of it. And there could be a sweet spot where the energy is above normal. So that just makes no sense at all. So now he's saying catapults are free energy devices. I don't think so. I suppose they would be if you used a heavy object to compress the catapult and then replaced it with a light object. Then they would be, or vice versa. Yeah, used a light object going fast to compress the catapult and then put a heavy object on it to release it. Then it would be free energy. because you get more for your money. So I linked to the Walter. Okay, so this is kind of, anyway. So I linked to the Walter Lewin video on a forum and brought up the subject. Luckily, the person who responded was someone I had positive interactions with previous, so they weren't defensive about anything and so on. After some back and forth, they basically said, yeah, you basically get a runaway momentum scenario into infinity, theoretically. Yeah, that is, So what's the explanation? There is free energy, or Professor Lewin committed shenanigans, right? I mean, I'm just saying that what can the possible errors be here? How could there be oh, we made a mistake doing the experiment? How could that possibly be? It's such a simple experiment. I mean, he pushes the thing on the air track, there's springs on it, it collides, and so the only thing you can say must have screwed up is the timer. But how could the timer screw up exactly this way? That doesn't seem possible. So something's amiss. I mean, I have to frankly say that when the heavier cart went away, it does look like it's going away faster than it should. So maybe free energy is real. And then you have to wonder, how could all the free energy nuts not have found this already? All the people trying to make perpetual, as a child, in my youth, attempted, theoretically to come up with perpetual energy, because I thought gravity, you should be able to steal from gravity, and I kept thinking, well, there's got to be a way to, make the weight go up in the easy side, in close to a bearing, make the weight go up easy side, and then make it go down the heavy lever side. So those kinds of, perpetual motion devices seemed, yeah, that should work. But, it doesn't work. I mean, I did draw it on paper and try to make it work, so yeah, I did think about it. But I also was informed by somebody when I asked them, don't waste your time, kid. It ain't gonna work. Though it's not a science forum, so I don't know if they'll get any further than this. I mean, the fact that you get them to concede something that theoretically, I don't know how you can put this together. How do I put these facts together and make something sensible out of them? And there's nothing sensible you can make. There's either free energy or there's shenanigans. And that's all you can say, really. Alright, so that's about it on the subject. And yes, I shouldn't even say on the subject. Well, this was on the subject, so no. Blah, blah. So, it is disappointing that, like I said, it's this should intrigue inquiring minds that are triggered by interesting questions that don't have simple answers, and it's just nothing, just nothing, not a peep of any kind of explanation. So anyway, leave it there, and I'll spend some time seeing if I can manage doing the experiment, but I really don't want to do it. I mean, I really just don't, like I said, I just don't know if I can do it well enough, make the space, blah, 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 all this crap. It's just a pain in the ass. We'll see. So if I have to do it, then I have to do it. I should just do it and get it over with, but it just doesn't appeal to me to be, doing things half-ass. But we should really get it done full ass. Okay, so anyway, until the next time and such, I think that's really enough. Yeah, close enough to enough. So, the continuing saga, and we'll see where it goes and such. See, even if the kinetic energy thing is right, and it does compress springs twice as much, even though they have the same momentum. I'm just trying. I can't see how you can possibly ever get out of the fact that more momentum is energy. That you can never have more momentum and say it doesn't mean anything. I don't see how it's possible for two objects to have different momentums and it doesn't make any difference. you know, they're the same. It just doesn't, how could that ever be possible? Anyway, how could Newton have gotten anything right if things with different momentums have the same impact in the universe? Just doesn't make any sense. Anyway, till the next time and such. This has been a DraftScience video presentation.